Hope you enjoyed Craig's and Dustin's sessions from this morning. If you happen to miss them, don't worry, they'll be available on demand at the conclusion of our spring summit starting tomorrow evening. We have two more great sessions today, each going into a specific territory or zone of automation. We're going to start off with Ryan Alt, who leads one of our key service delivery teams here at AHEAD. Ryan will introduce an effective framework for network automation, always a top priority of our clients. Ryan will then be followed by AHEAD's Stephen Aiello, who leads our security and compliance practice, to introduce another framework, this one for security orchestration and automated response, what we refer to as SOAR for short. As a reminder, please submit your questions by clicking on the QA icon underneath the video section. Each speaker will take questions at the end of their session. And please visit our sponsor booths to get some really cool informative content and win some cool prizes. And again, as a reminder, speaking of prizes, if you're kind enough to fill out our feedback survey, again, another icon on your console, you'll be entered to win one of 5 AirPod Max over-the-ear headphones that are really cool. We, of course, would love to get your feedback. So thanks again for attending day one. Please ask questions. And with that, I'm going to turn it over to AHEAD's Ryan Alt. Ryan, take it away.
Thanks, Tom. Hi, everyone. Thank you so much for taking the time to join me today. Automation is my favorite topic to discuss as it blends together my own background as a developer with what I love to do for a living, which is being a network infrastructure specialist at AHEAD. We have quite a few things to cover in just a short amount of time today. Because network automation is such a sprawling topic, we're going to focus on the key points at a high level in hopes that you can take today's presentation and use it to help you begin to construct your own roadmap for your organization and your own network automation efforts. First, I think it's really important to review some of the common pushbacks and challenges that network automation efforts face. And I don't just mean a few people writing scripts, I mean a well-organized and complete network automation program. Understanding where resistance comes from is key to knowing how to approach your efforts successfully. Second, and really the main theme of this presentation, is that in order to address those challenges and increase your chances of success, we're going to discuss a common framework for network automation. I'll emphasize that today's discussion is not a discussion about tools per se. We would need days and days to review all the possible tools choices for the various portions of the framework, not to mention the debates and rabbit holes we need to go into justifying one tool versus the other, given your own unique organization. So we're going to stick to discussing the framework, and I'm going to largely leave filling out that framework for another day and another discussion. Third, we'll walk through the components of the framework, what they really mean, and some common methods and tools we see used in the real world today. Lastly, I'll talk through a few common network automation use cases we typically encounter in our client base and how those use cases can be laid out in a logical progression using an automation framework. Let's review some of those networking automation challenges. And like I said, I think some of these probably will sound familiar to you. But the first is really, how do you even start? And moreover, how do you even sustain? Most organizations that I encounter on a day-to-day basis, they struggle with both of these things. Whether they're small organizations or even large enterprises, they generally have difficulty figuring out where to start, and it seems overwhelming. And then moreover, if they do get started, did they start correctly, and how do they maintain that progress? The second challenge that I see most often is there are just so many tools. As networking people, engineers, architects, and automators, we're pretty spoiled when it comes to tools. There is a lot to choose from, and along with that choice comes a lot of marketing information around some of these tools, especially some of that comes from vendors that claim that their product is all you need. We've all heard that before. And we all know that, in general, it's rarely ever the case that one product can solve all of your needs end-to-end, especially not in network automation. Fear is definitely probably the most salient challenge that I see in our client base, from large corporations to small organizations as well. When anyone ever hears network automation, they just think, well, now it's just a better way of bringing down my network. This fear has stymied countless network automation discussions that I've been in and that I've seen other organizations attempt in the past. Disjointed efforts are also a big challenge. What this means is maybe one or two people on staff are very good at writing scripts, but that's as far as it goes. And these scripts tend to remain on their laptops and don't get incorporated into a full process, resulting in some wasted time and basically scripts that can't be adapted or automation that can't be adapted to a fuller purpose. And lastly, and I think this one is also very important, insufficient commitment. When an organization isn't behind a network automation effort, along with personal commitment from the people that are doing it, the program isn't going to go anywhere. So how do we go about countering these challenges? There are many, many ways, but here are some basic guidelines to keep in mind. First, automating a network that's overly complex and fragile is an absolute recipe for outages. Keeping the network simple and as uniform as possible will allow you to automate much more quickly and effectively. Second, effectively automating networks requires a gradual shift to a different way of thinking and operating as a team. It's not just learning tools, it's not just reading blogs, it's changing the way that you approach the problems that you encounter on a day-to-day basis. DevOps principles like continuous integration are important to understanding why and how automation can be much safer than manual changes. As I mentioned before, there are more tools out there that claim to automate your network than I could possibly keep track of or really care to debate. And beware, again, of those who claim to be the only tool you need. In reality, certain tools work well in certain hands, but maybe not so much in others. Maintain a healthy amount of skepticism. Not everyone has to deal with large demand spikes and declines, so the need to automate for provisioning speed isn't as widespread as it can sometimes seem. Network automation's biggest benefit, in my mind and from my observations, is just the increased reliability you achieve through consistent testing and validation. And of course, automating networks requires reliable and accurate data about your devices, IP addresses, and so on. Without reliable information, there can be no reliable automation, period. A consistent framework can help pull together all of these guidelines and put them in a way and organize them in a way that makes them approachable and can help guarantee success moving forward with your own network automation program. So behold, the network automation framework. I'll pause for a minute and just mention that I've always been a details kind of person. For better or worse, my brain usually just needs to understand how things tick at a very minute level for me to feel comfortable with a particular technology or subject. But when it comes to success with network automation, you must pull back quite a bit and look at the effort holistically, then break it down into a few small components. Otherwise, you just get hopelessly lost in the details and never make much progress. So moving left to right, and in no particular order of importance, is the testing and validation component. Every automated action in a network needs to utilize automated testing and validation, and the methods by which you can test and validate really ought to be standardized as much as possible. However, some use cases will require not only standard tests, but will also require unique validation steps as well. Additionally, this component is also concerned with how we automatically roll back from a failed workflow with the least amount of impact possible, if necessary. The triggers and notifications component is really concerned with how we kick off our automation workflows, and of course, how we notify our administrators, engineers, etc., about the progress of that workflow. Build is mostly self-explanatory and probably the part that you're already the most familiar with. The build component refers to the scripting languages, tools, and other things we use to actually construct our changes and how we deploy them to actual devices. Sources of truth refers to the systems, the databases, etc., that hold the authoritative information on your network. These sources of truth are called on by our automation workflows to provide accurate information about the current state of the network. We'll dig into this topic much more later on, but this is an often overlooked component that requires a lot of care and attention to get right. And finally, tying it all together is orchestration. And you may know orchestration specifically as tools like GitLab or Jenkins, etc., and is the overarching platform that enables this automation framework. We'll discuss orchestration in a bit more detail shortly. You may be saying, well, this framework seems great, but where do I start? I don't think there is ever a perfect answer for everyone, but in general, exploring orchestration tools and how you will trigger and notify are the best places to start. And the reason being is that these two components will likely stay relatively the same over time, while your build tools and sources of truth will likely evolve over time. Additionally, adopting an orchestration tool that is already in use by your organization, maybe it's the cloud team or the DevOps team, for example, is often the best policy to ensure you don't need to build your silo even taller than it already is. Next, really digging into your potential sources of truth, mapping them out, and consolidating that information into as few sources as possible should be your next step. I'm not going to mislead you. This could take a lot of time, but it's worth it. Even if somehow your automation program falters for another reason, wouldn't it just be great to go through this exercise anyway? You might even save yourself some money through consolidation of this data. Testing and validation methods should be considered next, and really what I mean here are the standard methods that you'll likely use for every use case. We'll dig into what I mean by that shortly, but since use cases will demand tweaks to your validation methods, you can leave some of those more specific choices for later while mapping additional use cases. Third, picking your build tools may be a quick decision, or maybe not so much. Specifically, what you use to build configurations, query APIs, etc. is the point of this step and should reflect your use cases and skill sets, meaning it can and probably will change over time. Lastly, and really this is an iterative step, but thinking critically about your use cases is necessary to develop the momentum you'll need to sustain the effort. Specifically, not just thinking about changing a VLAN on a port, for example, but instead thinking what drove that use case in the first place and how can you automate the other steps involved. For example, how can you trigger that change and automatically test it once it's in place? This is starting to make a little bit more sense? I hope so. Let's move on to discussing some of these components in slightly more detail. In the orchestration realm, I've always been a big fan of GitLab because it builds in a lot of features in a mostly simplified package, specifically version control, continuous integration, and continuous deployment. However, many organizations already use tools like Azure DevOps, Jenkins, and any other number of choices out there. My main point is, if your organization is already using one of these tools, the best advice I can give is try to adopt what they are already using. It will go a long way in unifying your efforts with the efforts of other teams within your organization. But let's just go back to GitLab for just a moment. It's a great tool to learn on, and really best of all, it's low cost. It's just the price of compute if you're running as IaaS in public cloud, or maybe you're running it on-prem. If you stick with GitLab, I do strongly recommend switching to the hosted option at some point in the future to save yourself the maintenance headaches and worry over data loss. Having that running as a hosted option instead of maintaining the underlying infrastructure of GitLab just makes the whole system much more reliable and is a key component of the framework. Triggers and notifications. So what do I mean by that? So really, what kicks it off, and really how do you know what it's doing? Triggers for your automation workflows can really come in many forms, but the most common are listed here. Once your device configurations are maintained in version control, changes to those configurations via git commits and pushes are just a classic way to trigger automation. In this case, much like application code, it kicks off testing and validation checks on the configuration change, then it deploys to the device itself. Another common method, of course, is through an API call to your orchestration tool, which could be in response to a ServiceNow ticket or another external event, for example. This is often the case in the ticket enrichment use case, where a monitoring tool generates a trouble ticket, which then kicks off an automated information gathering pipeline. The information gathered from this pipeline can then be attached back to the trouble ticket to aid in quicker troubleshooting efforts by higher level engineers. For example, if a VPN to a branch office goes down, that could kick off a series of jobs that go out and collects information from the devices that are involved in the outage, or maybe some of the adjacent devices. The goal here is not to automatically troubleshoot, but the goal is to gather information and funnel it back up into the ticket to make it easier on the help desk when they're handing off the problem to a higher level engineer. We already discussed sources of truth and really their fundamental importance to network automation to a certain extent. To add on to what's already been said, developing an accurate and consolidated sources of truth is a process unto itself. Obviously, the first step is to gather up your own inventories, which could be contained in systems like Infoblox or another IPM solution, a change management database, maybe even a current configuration repository, or maybe even a tool like SolarWinds. Even network management platforms or SDN controllers like Palo Alto Panorama or Cisco's APIC for Cisco ACI are considered a source of truth because they contain runtime information about your network. The last thing I'll try to drive home on this component is that not only should you be focused on cleaning and consolidating this data, but you should also be thinking about how you can automatically validate this data against the network's current running state on a regular basis. So this could take the form of automatic checks, something as simple as like a cron job that runs an automation workflow that goes out and grabs a configuration from a device and compares it to the version stored in a repository. Many of you may already be doing this with older tools like Rancid and may haven't really even thought about it that much. So taking it a step further in the guise of network automation may not be much of a shift in procedure anyway. Let's spend a little bit of time talking about testing and validation because to me it's one of the most interesting components and it's such a huge important piece and really the enabler of network automation to be a boon for reliability and uptime. That's a key point here. At times, I think some think of automation as a way to subvert change governance. Let's just get around the people that need to approve change tickets and let's avoid those calls. It really is just the opposite. Network automation is also about automating and streamlining that change governance, not getting rid of it. Building in approvals along with automated testing and validation is exactly what our framework demands we do. Both pre- and post-deployment validation and testing should be built into every use case. Some simple examples of pre-deployment narratives may be, does the configuration even take? Is the syntax correct? And does this change have an impact on other operations I may not be aware of? Now, these validation examples or these validation methods can't predict everything, but they can certainly knock out a large percentage of the common causes of errors, following deployments. Post-deployment validation is exactly what it sounds like. It includes analyzing the impacts on what you've deployed into production. And this could be as simple as comparing running state of before versus after, or a more intensive application testing regimen, which I'm a huge fan of. Regardless, if these validations fail at any point, rolling back the change or canceling the deployment and automatically providing feedback via our notification channel is the overriding goal of this critical component. These are just some, and I emphasize some, of the pre-deploy testing and validation methods that I've encountered and I've also done quite a bit of research into myself. I'll highlight a few of the methods. If you've never heard of a tool called Batfish before, I strongly recommend that you dig into it. Batfish is a configuration analyzer that can take configurations prior to deployment and run them through an analysis engine to validate configuration syntax and even potentially impact depending on how much information you put into it. It's a great tool to provide just baseline verification that what you're about to commit into your network infrastructure is valid at a very basic level, and even in some cases at a very complicated level. Some of these other methods, such as templatized virtual appliances, are also great ways to test deployments prior to sending them out to production. And what I mean by this is perhaps I have, like, for example, a Palo Alto firewall, and I want to use a virtual version of that Palo Alto firewall on demand to test things like syntax. Maybe there's a rule I'm trying to create that I'm not quite sure it's going to work the way I want it to. There's nothing wrong with spinning up an entire virtualized appliance or really an entire emulated environment to do these tests. Really, you're only limited by how much time you put into it. Another common way that people do testing is through canary or blue-green testing. And really what this means is you're using a subset of production, for example, like designated leaf switches in a Cisco ACI fabric, to test your configurations prior to deploying it into its final destination in production. And the reason why this happens sometimes, or why it's needed sometimes, is because emulated or templatized virtualized appliances, et cetera, they're not exactly the real thing. They're not real hardware. And so in some cases, hardware testing is necessary, and really the only way to do that might be through canary or blue-green testing, depending on your environment. And of course, the physical lab, the complete duplication of production, I have yet to see anybody that's put the money into building a complete clone of their production environment. It's usually a subset or a microcosm of the production network, and that's perfectly fine as long as you understand that this is not a true and complete representation of the physical environment, so limitations may apply. Just a couple of quick examples of post-deploy testing and validation to kind of clarify this point. But post-deployment validation steps, they're really crucial to gauging impact. And really what's great about this is the tests that you do right, those libraries of tests can be amassed over time. And they kind of fall into two general categories. There's operational state analysis, where the state of the network can basically be captured prior to deploy and then compared to the state of the network post-deployment. That might sound familiar to you if you ever use something like PyATS and Genie. And this can really consist of real-time operational data like interface statistics, or it can just include configuration changes and comparing them before and after. And the other category generally falls into reachability and application tests. So simple reachability tests can be easily standardized and incorporated. Really simple things like ping and traceroute are just some of those examples. And then the part that I like to emphasize the most is application testing. So standardizing around application tests and operational state analysis through application monitoring tools like AppDynamics provide a really important layer of confidence that what you've deployed into production is actually working and didn't cause any unintended consequences. Version control, I think out of all the components, many of you are probably the most familiar with this. So I won't spend too much time on it, but version control is essentially using a tool like GitLab or GitHub with a repository to version your configurations, and then also for easier collaboration on those configurations in the case of network automation. Normally, these tools were developed to use for application code, but they're perfectly well suited to handle network infrastructure configurations as well. The one thing that I think people sometimes forget is these repositories are not only great, of course, for maintaining configurations and versioning in that sense, they're also really great places to store documentation. So if you have a Git repository, on GitLab or GitHub or whatever it might be, use that to store your documentation as well, especially if it's relevant to the automation that you're storing in that particular repository. It's a great way to keep things. It's a great way to keep things organized. So just jumping into common build tools, which I think is also another thing that you all are probably the most familiar with. The first two are the de facto standards, in my opinion, and I think in most people's opinions. Python, of course, it's a wonderful, wonderful language for someone that is educated in C++ development. Python is it's a godsend. The only thing that I'll say about Python is it does have some drawbacks, and I do think that it has a steeper learning curve than maybe some of the other tools like Ansible or Terraform, and I think in that sense some background in programming might be helpful. But that is not to say that you can't jump right into Python and use it for basic text operations and parsing and things like that. I don't mean to scare you away from it. I just think that to really take full advantage of it, you do have to put quite a bit of effort into it and maybe take some training to get up to speed. Ansible, of course, it's also written in Python. I think it's the most popular agentless configuration tool out there. I don't know what would really beat it at this point. But basically it uses YAML to describe intended state on target devices. The best thing about Ansible is because it's written in Python, you can always construct your own customized modules if you need them. Napalm, NetMiko, Paramiko, all the Mikos, these are just other tools that can help kind of abstract network devices in a common way. It's especially useful if you've got an environment with a mixed vendor setup, like perhaps your data center is Arista and your campus networking is Cisco, for example. And lastly, one of the biggest I'm a huge fan of HashiCorp Terraform. It's not really, you can't really compare it apples to Ansible, but Terraform is a great way to build infrastructure as code. And for example, use it in your testing and validation cases, especially when you want to spin up an entire environment, do some testing, and then spin it back down. Nothing better than Terraform, in my opinion, out there that can do that. So let's talk about use cases. So just a few real-world examples. And if you Google use cases for network automation, you're going to find a whole plethora of examples, probably similar to these, but these are the ones that I hear in real life and some of the ones that we've tackled for some of our customers. So the first one is, I would like a way to validate operation of our critical applications and services following any change within the data center network. Sounds familiar? Second, I would like our application teams to submit a ServiceNow ticket for the creation of new firewall rules based on their stated port and protocol requirements. These rules should be approved by the security team, but deployed as code in a pipeline. At times, this could mean on-prem and cloud simultaneously. And third, we would like to automate upgrades to all of our campus Cisco switches in response to a ServiceNow ticket. So let's drill into these a little bit further. Before I jump into this use case, though, the tools icons I used here are simply for context. I'm not making any specific recommendations here necessarily, so please keep that in mind. This use case is my favorite to begin with customers because it's almost completely devoid of risk, but it ties these concepts together in an approachable way. And not to mention, it addresses a real problem we see constantly in real environments, a lack of consistent and standardized testing following network infrastructure changes. In other words, we still see spreadsheets and late-night cutover bridges and all those sorts of things. And as such, thorough testing results like, hey, I can ping the server, I think we're good, tend to be the passing criteria. It's just not acceptable. Finally, developing a use case like this is great simply for the fact that it can be incorporated into future workflows as a repeatable module. How awesome would that be? Our second use case example dials up the complexity a little bit, but it builds on our previous use case. So larger campus networks, especially of monolithic switches, and what I mean by that is non-centrally controlled devices, so not Cisco SD Access or Arista's competing solution, but all the campus networks that you're probably familiar with individual switches in every IDF and MDF closet. That is a huge headache to maintain. Especially when it comes to upgrades and also configuration validation. So this is a great use case for us to jump into next. Automating that pre-upgrade testing and then the upgrade action itself, building in post-upgrade testing, and then configuration validation of devices is a fantastic place to go to next. And let me be clear, there is nothing wrong with using management platforms as part of the process. Things like Cisco's DNA Center, for example, that can just become another component within the framework to use in these use cases. Lastly, a more complex use case we hear about in the real world often is the process of automating firewall rules deployments through a change ticket or service request. This is a much more complicated use case if you can't tell, but it can have a big impact on reducing the time spent waiting for firewall changes following an application deployment or an application change. At the same time, this maintains the governance that is so important to any organization. So really, it increases the visibility and the governance around some of these use cases just by using network automation and this kind of a workflow. So think for kind of a more detailed example, if I'm an application developer and I'm deploying an application change to production and I need a new port opened on my server, I can submit a ticket. That ticket can be, of course, reviewed by a security person that understands the impact of that change. They can go off and they can do the research on that port and protocol just as they would before. But once they're finished doing their analysis and maybe they're modifying the ticket itself to change how it's being deployed, they come back and they could hit a button and that could kick off an automation pipeline that goes off, does some pre-checks on the configuration, builds that configuration, tests that configuration, does additional pre-deployment checks before it deploys into production. It deploys into production. It does all the post-deployment checks, especially testing the actual rule it just deployed. Instead of just saying, okay, the firewall's rules in, okay, application tester, go ahead, it's your turn. We can automate that using any number of methods. And then that can provide feedback into the automation pipeline that the change was successful. So I'll quickly wrap up our discussion and leave you with a few key takeaways. If you haven't gotten the message yet, adopt a framework and spend the time developing the plan. Taking it piece by piece, you'll build something that can last and adapt to natural changes in your organization as well as the underlying technology that you're using. Unless it truly applies to you, try to push the need for speed aside. Focus instead on using automation to increase the uptime and manageability of your enterprise network. Not only is it a more applicable and realistic driver, it's also a better way to sell a network automation program to your leadership. Lastly, and this point is personally very important to me as a people manager, use your automation efforts to form relationships with the other teams in your organization. Networking people naturally stitch everything together, and a key to success in that respect is learning to speak the languages of other teams. I've made this a priority in my own organization, and though there's always more to do, it's paid off well in terms of attracting talent and also boosting morale amongst my team as they form those relationships. Thank you so much for your time and attention today. I hope this was informative, and I hope this talk has helped you kind of think about some of the ways that you can create a lasting network automation program in your own organization. And to that, we'll open it up to questions. Thank you.
Hey everybody, this is Ryan. So we'll go into questions. So the first one is, it's a good question. Have you actually seen anyone put together a full network automation program as you've described here? Not that many times. I've seen it once where a customer had an entire center of excellence put together around, really it was mostly around cloud. It also involved some on-premises aspects as well, but it was chiefly focused on cloud. But to answer the question directly, just about everybody that I encounter, and again, this is limited to, kind of my experience and the clients that I visit, most of them are at some stage in the process. And a lot of them are kind of at the beginning. And that's why I wanted to stick to kind of an overview of the process today, because I think a lot of good can be done by just simply getting started by, adopting some of those testing and validation use cases that I mentioned earlier. Second question, on the orchestration slide, there are two areas you covered: orchestration and configuration management. On the provisioning side, there is either Terraform or not so agnostic tools like CloudFormation. Also in the earlier session, I had talked about business ticketing orchestration. Any trends you see with respect to the following areas: configuration management, Ansible, orchestration, Ansible Tower, provisioning, Terraform, and process and business orchestration? I think we're a little biased because we're a big HashiCorp and ServiceNow partner. So the vast majority of clients that we encounter are going to use ServiceNow as far as triggering and ticketing goes. So that's just by far the one that I see the most outside of just network team triggered automation, like configuration updates, infrastructure as code models, that sort of thing. Ansible is definitely the chief tool that I see. I think it's so pervasive. Most of the vendors out there, Cisco and really anybody else, you can tell there's been an effort to kind of dedicate a lot of care and attention to the Ansible community with the writing of different modules and just the vast amount of information that's out there with respect to like playbook examples and that sort of thing. Ansible just to me is a great place to start, especially if you don't have like a lower level programming or an interpreted language background. Ansible is just a good way to start there. Orchestration for Ansible Tower specifically, I would say we see Ansible Tower quite a bit. I'm involved in kind of 2 active engagements right now where we're using Ansible Tower. One of them is a POC kind of approach. The other one is where they have a pre-existing deployment. But I see Ansible Tower quite a bit, and it's just a logical thing to go to when you're moving past just running Ansible on your laptops. For provisioning, so for Terraform, and not to get into the kind of the ins and outs of it entirely, but Terraform, like its whole purpose is to create a thing and then destroy the thing. It's not such a, and I might be mixing my terminology here, it's not such a configuration management tool because it's more meant to just create and destroy. And like we use it a lot, I would say principally in public cloud. So most of the guys and gals that are on my team that work on public cloud networking projects, I would say the vast majority of those projects are done with Terraform. It's just well suited to that. And then, kind of going back to the CloudFormation mention, Terraform is going to work across different public cloud providers versus kind of dedicating your efforts towards, something like ARM or CloudFormation for AWS, for example. So it kind of maintains some flexibility there. And then as far as like the other tools like, Jira and et cetera, I would say that I still see mostly Azure DevOps. I still see some Jenkins. Again, and kind of going back to what I was saying in the presentation, I don't think that there's anything particularly wrong with one choice or the other, but if your organization's already settled on one and, your server team uses, Jenkins, for example, currently, that's what I would do. I would try to stick with what they're using, just so that you guys aren't rowing in a different direction. Okay. Next question. How do you encourage traditional network engineers to take the leap, especially if they have zero application development and coding experience? It's a really good question. I think where you need to start is learning something like Ansible. I mean, just basically forget, all the other things that they need to tackle and really just focus on Ansible and getting some very, very basic experience on Ansible. I think before I kind of go any further on that, though, I think, some engineers some of them are just not going to want to operate that way. I think some of them are just, they're used to the CLI. They're used to just popping in and configuring a VLAN on a port. And I get that. I do. I really, really do. And I see it a lot. But if you can get them to kind of look at it as, well, remember that time you brought down that network, when you changed the STP priority of that root switch, remind them of those cases where you didn't build in automatic testing and validation into some of those even simple changes, I think is enough of a reason to kind of look at, shifting focus over to a framework that can incorporate testing and validation into the pipeline. And, but again, like it's an investment in people. I think a lot of these things are going to require training and they're going to have to happen and they're really going to have to unfold over several months. So this is something that just isn't going to happen overnight, of course. But committing to it and instead of going off and configuring that VLAN on a port manually one day, just say to yourself, okay, you know what, today I'm going to do this with Ansible and I'm going to test it in our test lab first. And then I'm going to go off and do this. I think is kind of it's not too much to ask someone to kind of take a first step. There's a multiple. So if there are multiple approval levels for a given use case across different teams, how do you integrate that? Yeah, good question. It depends on what tool you're using. I think, for an orchestration tool like GitLab, I'll just kind of boil it down in simple terms. So like with something with GitLab where I'm building a pipeline, I can have certain steps that are required for approvals on commits before I let it go to the next step. That's kind of a more direct way of doing it. And if I'm operating just within the networking team, I think that's, a fine approach. If it's unified in something like ServiceNow, we might be doing things like, ServiceNow kicks off a job, it creates a ticket, that information gets fed into the pipeline. And then when the pipeline is at a point where it needs to stop and get further approval, Ansible has built-in modules for this for ServiceNow, but it can go and update that ticket in ServiceNow with, okay, I got to this point, further approval is required. And then someone could, look at what the output was, approve it again, and then it can keep going on in that pipeline, for example. That's just kind of a real rough and tumble example of how you could approach that problem. I don't know all the tools and all the ins and outs of all the tools, so there might be a much more streamlined way to do that. But the design of this needs to include, just to your point, is where do I stop and a human looks at this for context before I send it out. We still need humans to interpret the data, I think, to a large extent. And it's a good question. And I think it can definitely vary depending on, the organization and the tool sets you have. But those things can generally be built into just about any tool that I've ever seen. Yeah, so this is a really good one because I'm dealing with it this week. When you run into orgs where the Ansible Tower product resides on a separate team, what has the network team's involvement been with the network automation creation? Is Ansible access extended to the network team, or does the network team make requests to the team that owns Ansible and they work hand in hand? I would be lying to you if I said we've got a solution that applies to everybody for this. I think just like the orchestration tool, I think every effort should be made to combine, use cases onto the same instance. And those people should be working together on the administration of those instances. Personally, it's some work that I have to do on my side. I think even for me personally, like my team is very proficient in Ansible and Ansible Tower. We don't really get wrapped up in the administration of Ansible Tower, which I think is a mistake. I think we need to understand the platform better as a team because we generally hand that off to my colleague Dan Wittenberg's team to handle kind of that administration. But I think we need to do a better job of kind of integrating ourselves too. But I think my general sense there is combining on the same instances is a good idea, especially if you're trying to look to save licensing costs, because I think Ansible Tower is licensed on a node count. I think it's like in 100 packs, if I remember correctly. So there might be some chance the cost save there. And then I think we've only got just a minute here, so I'll do one more question. Let's see, Azure. Sorry, looking at this here. So my team has a good amount of experience and comfort using Ansible, but not much more beyond that. What should they focus on learning next? Good question. I would focus on learning your repository next. I would learn how Git works, so GIT, and then I would extend that into your own repository. You can obviously go to any public cloud provider like AWS as code commit, and there's no end to those types of repository SaaS-based tools. And this is just me. I kind of like just building it out myself, and spinning up a GitLab instance in my home lab or on my AWS account, and then playing around with that just to kind of get a sense of like the nuts and bolts of it and how it works. And that's where I would go next, and then evolving that into, okay, now that I'm on, a certain platform like GitLab, how do I start, excuse me, how do I start building in like continuous integration pipelines? How do I start with just committing code, testing that code with something like Batfish, and then outputting those results without deploying anything, and then just kind of proceeding on from there. Okay, I think that's all the time we had for questions. Again, thanks a lot for attending, guys. This means a lot to me to get so many good questions. I appreciate it. And then just a reminder, if you could stop by the sponsor booth, and then also please fill out a survey if you have the time. I think that would mean a lot to us if you could kind of give us some feedback just to tune these sessions for future use. And with that, I will introduce Stephen Aiello in the next session, and that'll be all for today. Thank you.